let's test our understanding with some examples. So the first example is, let's consider a pure state. I want to consider a pure state, which I know I can describe by a single wave function, psi. Let me suppose I'm in the state of a qubit, 0 on subsystem A, tensor 1 on subsystem B. So right up front, this is a separable state. I know that the state of the component A should be 0, and the state of component B should be 1. So we just want to check from our definition that that's still true to see why this is a sensible thing, a sensible way to define it. So the first question is, how do I write down what the density matrix rho AB is for this case? This is where you have to use the fourth postulate for density matrices now, which I erased. But try to do this. Take a minute to yourself and try to write down what rho AB would be for this pure state described by a single wave function, psi. All right, so in this case, I'm just going to use our definition. It's going to be 0, A, 1, B. And then it's always the outer product, so you can put it in parentheses if you'd like. So now it's going to be 0, A, 1, B. And now just have to ask yourself, how do you evaluate? How do we evaluate operators across a tensor product? So if you'd like, you can always put the tensor product back in to make it easier. Well, this is going to be 0, 0 on subsystem A. What's that? It's everything on the left of the tensor product. So it's this outer product. And then it's going to be tensor this outer product, 1, 1, subscript B. You can, if you'd like, use the subscript A on both the ket and the bra, or you could just put it on 1. You could also just omit it in this case where it's clear, from the tensor product. So you'll see these various notations, but here I'll just use one subscript, A and B. Okay, so this is our density matrix, rho AB. And again, already it's a separable state, right? I can write it as something on A, tensor something on B. That's still our definition of separable for density matrices. So we know in advance that the state on subsystem A should be 0, outer product 0. We just want to check that from this definition so that we can gain some more understanding of what this definition is doing for us. So let's try to do that. Let's compute rho A. In order to do that, you have to evaluate the trace over B of rho AB using this definition. So take a minute to try to do that.